Okay, so for part one, starting off with intercepts. And we're going to see intercepts in all different versions in this course. So like any kind of an equation can have an intercept. But kind of the key thing with intercepts is if you're looking for an x-intercept, it's going to have the form, some value and 0. So to find any x-intercept, no matter what kind of function we're looking at, we got to let y equal 0, and then that puts us on the x-axis. Likewise, to find a y-intercept, we're going to let x equal 0, which puts us on the y-axis, and then solve for the y. And so that's going to be true whether we're doing linear functions, quadratics, rationals, exponentials, logs, whatever we got coming up. Those two ideas, to find x, let y equal 0 solve, to find y, let x equal 0 solve. We'll see that over and over this quarter. So here it is with linears. And in this, we're going to have equations. We got two forms here for the equation of a line. And this is kind of coming up, but I'll just point them out right now since I have examples of each. This is what's called standard form. So they're going to be a, b, and c are going to be integers, which means not fractions. And then the x and y are on one side. So that's standard form of a line. And then we have slope intercept, which hopefully you've seen in a previous course. That's that y equals mx plus b, where m is our slope and then b is our y-intercept. And so those are kind of the two versions of this that we're going to see throughout. We'll also pick up point slope in the second video. So for this one, when we're in standard form, finding the x and y intercepts is often a really good way to get something graphed from this form. Not the best way to get something graphed from this form, but pretty good for this one. So here, if I let x equal 0, then I'm going to be solving for y, right? So 4 times 0, that piece would drop out, and I would just have negative 5y equals negative 20. There I can divide the negative 5 over, and I would have y equals positive 4. So as an ordered pair, that would be when x is 0, y is 4. And then to find the other intercept, we're going to let y equal 0, and that'll let us find the x-intercept. So when y is 0, this piece drops out, and I'm left with 4x equals negative 20. Dividing the 4, we get x equals negative 5. And so as an ordered pair, when x is negative 5, y would be 0. And then once I have those 2 points, this one would be x is 0, y is 4 would be here, negative 5 is 0, so I'm back here. Then that's graphing using the intercepts, and I got the graph of my line. So that's actually a pretty nice way to get that graphed. And I showed a lot of steps here when I'm doing this for myself, right? I'm just going, okay, when x is 0, this is gone. Negative 5 into negative 20, that would be 4. When y is 0, that's gone 4 times, it'd be negative 5. So you can really kind of shortcut this down, but I'm just kind of trying to show the steps in this first example for these, but that's kind of what I've been doing in my head. So pretty quick way to get them graphed from here. For this, that's totally not how I get a graph. This, I would start at negative 8 and then use my slope, which would actually go this way. But this question is specifically asking us to find x and y intercepts, so let me show that. So if I let x equals 0 here, I would have y equals negative 3 times 0 minus 8. And you can see that that term's always going to drop out when an x is 0. And so that is why this value on the end is going to be the y-intercept. So when x is 0, y is negative 8. We don't even need to do that math if we're in slope-intercept form because y-intercept's right there. Okay, so then let's find the x-intercept. So for that, we're going to let y equals 0. So we'll have 0 equals negative 3x minus 8. Add the 8 over, so that gives me 8 equals negative 3x. And then divide both sides by negative 3. And that gets us x is negative 8/3. So that would be negative 8/3 when y was 0. So those are my x and y intercepts for that one. Okay, so this one has a fair bit of writing to it, and this is sort of how the question will look on the computer screen. So I'm just trying to give you an idea as to kind of what you'll encounter when you see the actual questions. So Diana graduated and wants to spend time off in Sacramento. Before graduating, she saved $8,450 for this trip and plans to spend $650 per week for food, rent, and activities. If she graphs her amount A of savings in dollars, A's how much money she has, and time 10 weeks since the trip started. So now, which variable would represent the dependent variable and which would represent the independent? So remember we saw back in chapter 1, independent variable, that's kind of like what we would normally think of as y, and then the independent variable is what we would normally think of as x. It's the input is the independent, the output or dependent. And so she is wanting to find, if she graphs her amount A of savings in dollars and the time and weeks since the trip started, feels like she's going to have this much money, and we're going to figure out how many weeks, right, she can live off of her money. So I think T is going to be our independent variable. We're going to want to put in time, and then we're going to see how much money she has left. And so this will be like a check the box for which one. So it'd be, T would be independent, and the amount of money will depend on how much time has passed. You could write it the other way, but it doesn't make sense, at least to me. B, on which axis would the variables be most commonly shown? Okay, so that's what we're just kind of saying there. So the independent variable is generally shown on the horizontal, and then the dependent is generally shown on the vertical. And so A would be vertical, and then T would be horizontal. So that'd be that one. C, give the coordinates of the vertical intercept. So if in our vertical intercept, that was this amount A, and so that would be how much money is she starting with. So that would be right here. At time 0, she had saved $8,450. So that would be our vertical intercept. And then give the coordinates of the horizontal intercept. Okay, so the horizontal intercept, that means she's going to have no money left, right? Because our amount will be 0. And she is starting with $8,450. And then each week she's intending to spend $650. And that would be T. And so now, if you're starting with this much, and this is how much she's going to spend each week, now I can solve for that T and figure out how long until she's out of money. So I'll bring this over. And then divide over the 650. It looks like T comes out to 13. And so that would be 13, 0. And so then part E on this question is, what does the vertical intercept represent? And so again, if we're kind of thinking of this graph, the vertical intercept would be how much money she had at the start of the trip. So that was how much she had saved. And then what does a horizontal intercept represent? Remember, that's when the money, her amount is 0. So this is how long 13 weeks is when she's going to run out of money. Hey all, this is Derek, and this is section 2.1, rates of change and linear models. So let me go through, well, this section is about slope. Rates of change is that's kind of code for slope. Let me go through some of the kind of the hopefully elementary algebra stuff that you've seen, and just kind of refresh your memory on some of the notation and what the idea of a slope is. So basically what slope tells us is how much the y coordinate is going to change for each change in x. So if I go over 1 in x, what happens to the y? And that ratio is what slope is. In other words, rise over run is a common way of thinking of it, or vertical change over horizontal change, or a little bit more formal version is this delta y, delta x. And what the delta stands for is just change in. That's what this Greek letter we use that for in math, is change in y over change in x. So it's the same way as saying vertical change and horizontal change in rise and run. Also, slope is abbreviated with the letter M, which is not intuitive, but it is what it is. Let's see, I think I got that. Linear functions, which is what we're looking at in this chapter. Linear functions have a constant slope. We'll look at ones in the future that do not have a constant slope, and that's where it starts turning into calculus. But we will see that in some future sections. And then algebraically, remember we had that slope formula, y2 minus y1, x2 minus x divided by x2 minus x1. And so that's kind of our toolbox for slope. It's all the same thing. It's just sort of different versions of saying the same stuff. Let me show what that will look like in an assortment of examples. So this first question is asking us to find the slope of each line, and this is just based on a graph. So what we want to do is identified 2 clean points, so it looks like I can get a good look there and a good look at that one. And then we draw in a triangle, and that helps us identify. We don't have to draw in the triangle, but I'm going to draw in the triangle, and that will help me identify my rise and my run. So it looks like in terms of the run, we're going 3 units on X. And in terms of the rise, we're going in the positive direction. It's going up. If something's going in the negative direction, that would be going down would be the negative direction. And the rise on this is going to be positive 4. So my slope is 4/3. For this one, if I grab that point, and it looks like right here, now my run is 1, but notice this time the graph is decreasing, and so that's going to be a -5 because I'm heading in the negative direction. It's getting smaller. And so now m is -5/1. Don't put that in the computer. Make sure you simplify your fraction to -5. Otherwise, I think it tends to mark that one wrong. These next 2 are kind of the special cases. So this is going to be a horizontal line. Again, arbitrarily just picking 2 points on the line. So if I do rise and run, in this case, the rise, there is no rise, so it's 0. And the run for the 2 points I picked happens to be 3, but 0 divided by anything other than 0 will be 0. So flat line, 0 slope, makes sense. And then vertical lines, here if I do rise over run, for the ones I picked, the rise happens to be 3, but notice the run is going to be 0 everywhere. So we're getting a number divided by 0, and that's undefined. In the computer, I think it wants you to put D and E for does not exist, but the slope will be undefined in that case. Okay, number 3, a company discovers that to produce 735 components, it will cost this much money. To produce 775 components, it will cost that much money, and I just caught that typo. Compute the slope of the costs and complete the statement below. Okay, so let's get our ordered pairs set up just so we can see them. So 735 components costs $21,400, and then 775 components costs $22,280. And so now we're just going to find our slope. So we'll do our y2 minus y1 over x2 minus x1. And then doing that subtraction, up top we're going to get 880 divided by 40, and so that's going to be 22. And they're supposed to complete this sentence. So the costs are increasing or decreasing. It's positive, so it's increasing at a rate of $22 per unit. And that's because if we look back at our equation here, this is dollars over units. So my slope is coming out $22 per unit. Okay, and then this next part is horizontal and vertical lines. So we looked at their slope already, and these are just a couple of special cases, so I'm going to get those introduced now. Horizontal lines always take the form of y equals b, and the slope is 0, like we saw in that earlier example. Vertical lines are going to take the form x equals a, and then the m is undefined, as in that earlier example. So one thing with this is horizontal lines are y equals, and that is backwards what your brain's going to tell you. It actually makes sense, but we think of the y-axis, right, goes vertically. So you just have to be careful. Y equals is going to run horizontally, and the reason for that, and this I'm supposed to sketch a graph, state the slope. So y equals 3. When x is 0, y equals 3. When x is 1, there's no x in the problem because it doesn't matter. Y is still 3. When x is 2, y is still 3. So for a constant value of y, what we do get is this horizontal slope. And then m is 0 for all horizontal lines. Sketch a graph of x equals 3, state the slope. So here when x is 3 and y is 0, x is 3 and y is 1, and y is 2. So you can see for a constant value of x, those are all going to line up vertically, and then we get a vertical line. And then this is the one where the slope would be undefined, or D and E in computer speak. Okay, and then last thing for this section is graphing lines given a point and a slope. So we do not need an equation. In this case, we are given an equation, but we don't need an equation to graph a line. All we need is a point, and then we just have to know which way to go. So graph the line through the point -2, 4. So x is -2 and y is 4. So there's my first point. And I have the slope of -3/5. So remember, this is rise and this is run. And that's between any, points, it's going to have this ratio. So if we run 5, we'd go 1, 2, 3, 4, 5. And if we rise -3, that would be 1, 2, 3. And then that's our line. For this one, sketch a graph of this. So remember, this 1 was kind of our starting amount. So it's going to be our y-intercept. And in the next section, we get this a bit more formal, but I'll write it here. Y equals mx plus b. So b ends up being our y-intercept. When x is 0, what would this come out to? 0 minus 1 would be -1. So that's where we think it was our start. And then the 1/4, that's that rate of change that we've been looking at, our slope. So rise and run. So this one's going to run 4 and rise 1. Okay, so then the second topic in this video is going to be finding the equation of line and slope intercept form. And so that's where we're going to use this y equals mx plus b. And so again, m was our slope, and then b is going to be the y-intercept, which we've seen a bunch of times, but now we're just doing it a bit more formally, given a point and a slope. So I'll be using this a bunch for these next examples. Okay, so 4 is find the equation of a line with the slope of 3 passing through the point 8 and 42. Write your equation in the form of, that should say y equals mx plus b right there. Okay, we know m is 3, and we know the point is 8 and 42. And so what that is an xy. That's an ordered pair that's going to satisfy this equation. And so I'm going to just put the 42 in for the y, and then mx, so m is 3, x is 8. And what that does is gives me everything but b. So once I have a point, I can use that point with the slope to solve for the y-intercept. So 42 equals, I'll be 24 plus b, and we'll slide the 24 over. And that is going to be 18. So writing down our answer, we got y equals m, which was 3, x, and then plus 18. So notice the x and the y, those stay variables, right? The two things we need to find when we're finding our equation is the slope and the y-intercept. Sometimes they will just give you the slope like they did in this one, and then sometimes you'll have to kind of work to get the slope, which will be the next example. All right, number 5, an elk population in North Cascades grew from 150 in 2015 to 198 in 2019. Let t be the number of years after 2015. So what that means is in 2015, we're letting t equals 0. And then p is going to be the population of elk. So write the ordered pair t comma p from these data above. So 150 is going to be my population. So a couple of things going on. One, we got to shift t. 2, they wrote the points backwards. So t is supposed to go first, and 2015 is now, we're calling that 0. So that first point is going to be 0, is 2015, and the population that goes with that is 150. So hopefully that makes sense, that we're letting 2015 be times 0, and at that time the population is this many elk. And then the next time we're given is 2019, which is 4 years later, so we're going to let that be 4. And what it lets us do is not put giant numbers into the formula we're making. We get to get a little bit cleaner numbers to work with. And at that time, the population is 198. So that would be our ordered pair for this data. Find the change in population. So remember, delta means do P2 minus P1. So it's change in. So change in population, delta P is going to be 198 minus 150, which would be, the change in population was 48. Okay, so then to find delta t, we're going to go 4 minus 0, so delta t will be 4. And then to find the rate of growth, that's our slope, so change in population over change in time. So delta t will equal 48 over 4, or 12. How much did the herd grow each year? What are the units? So the herd was growing at 12 elk per year. And that's because, remember, this is population and this was time. And then F is write a linear model for P in terms of T. And remember back here we set 2015 as T equals 0. So that means we already know our y-intercept, so that makes this pretty easy. P will be 12 times each year plus the 150 that there were in 2015. Yeah, this is part 2 of the 2.2 video. So picking back up at finding the equation of a line in point slope form. So point and slope form is this right here. And what it is if you take, if you remember our slope formula, y2 minus y1, and then x2 minus x1, and I multiply both sides by x2 minus x1, then basically that's the exact same thing as point slope form. And in this case, m is still a slope, and then the x1, y1 is a point. But rather than here where we had them both as points, here our other x and y are going to remain variables. And so what we can do is we can kind of set things up in this, and then it's really easy to get into slope-intercept form from there, or just leave it here. Once we learn a bit about transformations in a couple more sections, this actually will pertain to how we could look at lines in terms of transformations, but that's not for a couple more chapters. Okay, so for here, we're supposed to write an equation of a line with a slope of 2/3, which passes through that point, use point slope form, and then B, change it over slope intercept, and C, graph the equation. So, writing this in point slope form, we're gonna have y minus y1, and same issues when you're doing slope formula, you gotta be careful with the double negatives. And I'll clean it up in a second here. M is 2/3, and then X, and again that minus happens to be a -3. And then without all the silly double negatives, we'll go y plus 4 equals 2/3 x plus 3. And so in terms of write it in point slope form, that's it. That's what we got. Write it in slope intercept form. Okay, so now I'm going to go ahead and distribute the 2/3 and then bring the 4 over and get the y by itself. And then it'll be y equals mx plus b by the time I simplify everything. So this will be y plus 4 still, and then let's get that distributed. 2/3 x, 2/3 of 3, the 3's cancel, leaving just the 2. And now I can subtract the 4 over. And y equals 2/3 x, 2 minus 4b minus 2. And so now to graph this, I can start at my intercept, -2, and then I know my slope is 2/3, so I'm going to run 3, 1, 2, 3, and the rise 2, 1, 2, and then that's my second point. And if we go back to what we were given, this point should be on this graph if I didn't screw anything up. So when x is -3, y should be -4, and yep, there it is. So that's a nice way to double check that everything went well here. Hey all, this is Derek, and this is section 2.5. This could be applications of linear functions. So I don't think there's actually really much new in this section. It's just going to be kind of a collection of finding the equation of the line, but sort of given different prompts in sort of application settings. I don't think it's too bad, honestly. So we'll see. First question we got, in 1994, the moose population in the park was measured to be 4,260. By 1997, the population was measured again to be 4,860. If the population continues to change linearly, A, find a formula for the moose population P in terms of T, and that's going to be in years since 1990. So what this year since 1990 thing means is to let 1990 be T equals 0. And what that does is it sets a smaller value for T so that we're not working with such huge numbers for the equation. So let me write, as I like to do, let me write out the ordered pair. that this information would be then, just so I get everything in the right spot. We are finding the population in terms of t, and so that means we are putting in t and we're getting out population. And that doing that kind of helps me from writing things backwards. So they told us in 94, which would be t equals 4, the population was that much, 4260. And then in 97, so that would have been t equals 7, population's 4860. And so then we can find our slope. So we'll do m equals our change in y over change in x, or in this case, change in p over change in t. And then evaluating that got me 200. And then once I have this, I can either do point slope or slope intercept, either one. I did slope intercept in the notes, so I'll do that. So I went 4260, that's my y equals m, which is 200, x, which is 4, and then plus the y-intercept, because that's the other piece I need. So remember, we need to find slope and y-intercept to get our equation. So this is 4260 equals 800, and then subtract the 800 over, and we get 3460 equals b. So then our equation would be the population is going to be 200t plus 3460. What does our model predict the moose population to be in 2007? So 2007, that would be 17 years later, right? And so we're just going to evaluate this at 2007. So P equals 200 and then 17 plus 3460. And I just chucked all that in the calculator and got 6860. Number 2, suppose that the world's current oil reserves are capital R equals 2,010 billion barrels. So they're using the word billion so that we don't have to write out like 9 zeros, which will make our equation a little bit more manageable. If on average the total reserves are decreasing by 21 billion barrels of oil each year, answer the following. First, give a linear equation for the total remaining oil reserves R in billions of barrels in terms of T number of years from now. Okay, so let's see. We know we are starting out with 2,010 barrels, and then that's going to decrease by 21 billion barrels per year. And so our reserve is going to be negative 21, because we're going down 21 each year, for each year that passes. And we're starting from 2,010 barrels. I could also write this the other direction. I could say starting from 2,010 barrels, it's going to decrease 21 for each year. And these are billions. I keep saying barrels. Both of those are right. This is in terms of, the kind of the y equals mx plus b, that's the form. I think this makes a little bit more sense when I think about it, but this is probably the form that we write it in. So the next 66 years from now, the total oil reserves will be, cool, so we would just toss 66 in here, and when I did that, I got 624 billion. And that if no other oil is deposited in reserves, the world's oil reserves will be completely depleted, all used up approximately how many years from now, round to 2 decimals. So it's asking, when will the reserves be 0, right? That's what this completely depleted, that means R equals 0. So what we're doing is we're just finding the intercept, the X intercept, which is now a T intercept. So 0 equals negative 21T plus 2110. And then I'll just add that over. Negative 2110 equals negative 21T. Divide negative 21 on both sides. And then that came out to 95.71 years. Okay, parallel and perpendicular lines. So parallel lines, they're ones that track each other, and 2 lines are parallel if their slopes are equal. So if the first slope equals the second slope, or M1 equals M2, then they're going to be parallel lines. For two lines that intersect at right angles, those are going to be called perpendicular lines. So like for instance, these two lines right here are intersecting at a right angle. So those would be perpendicular. And then the two lines are perpendicular if the product of their slopes is -1, that is if m1 times m2 equals -1. And there's a kind of an easier way to think of that. And let me just do an example that's not in the notes here, but just to kind of show this other idea. So if I had a slope 2/3, and I was trying to figure out what I would need, what would the perpendicular slope be that would make that multiply to -1? M perpendicular, and that's a little symbol for perpendicular is an upside down T, is kind of what it looks like. So to figure out what would make this come out to -1, all you gotta do is flip over what you have, take the reciprocal, and then use the opposite sign. So since this one's positive, this one's negative. And then you can see if I multiply those together, I would get -6/6, which would be -1. If my original slope was, say, 4, -4, that's really like -4/1. So then my perpendicular slope would be 1/4. So it would be positive and then reciprocal. You can see I get -4/4, -1 again. So this is the official definition. But I think if you think of it as I'm going to take the reciprocal and change the sign, it's an easier way to get there. And then what we're going to do with that is, at least for now, just use this to practice finding equations of lines. So give the equation of a line that goes to the point -2, 6 and is, in the first case, parallel to this equation, and then same equation, second case, find the same one perpendicular. So what they're saying is we have some line out there, and we have this point on x is -2, y is 6, and so we want to find the equation of the line parallel to this one that's given, and then also perpendicular through this point to the one that's given. And so the first thing we need to know then is, if it's going to be parallel to this, what's this one's slope? Because once I know that, then I can get the parallel slope and I can get my equation. So let's get this in y equals mx plus b. So I'm going to subtract the 3x over. So that's going to be 2y equals -3x minus 8. And then let's divide everything by 2. And we get y equals -3/2 x minus 4. So that means the slope there is -3/2. So the slope parallel is also -3/2. So now I'm just trying to find the equation of the line that goes through this point that has this slope. So it's just like the problems we were doing earlier. And so you can do this as point slope or slope intercept, either one. I'm just going to do slope intercept, but they're both totally fine. And so here we'll put in 6 equals -3/2. X is -2 plus b. Here the 2's would cancel, and 6 equals, and double negative will be positive. So 3 plus b. And subtracting that over, we'd have b equals 3. So the equation of the line through this point parallel to this line would be y equals -3/2 x plus 3. So then for part B, for perpendicular, if our original slope was -3/2, then m perpendicular is going to be positive 2/3. And then we're still using the same point, -2, 6. So this time, because this fraction is not going to clear nicely, I'm going to use point slope form and show you a way to kind of sneak around dealing with the fractions. So right here, I'm going to go y minus y1, so that's the 6. And then it's going to be m, which is the 2/3. And then x minus -2, so this time I'm just going to write that as a positive 2. So I could distribute the 2/3, and then I would have 4/3, and I'd have to come over here and combine the fraction. That's one way I can go. I could also multiply both sides by 3 for a second, and what that will do over here is get rid of the fraction for me, and then to balance it out I had to do the other side by 3 as well. But 3y minus 18 equals, and now this would just be 2x, and then 2 times 2 makes 4. And now I'm gonna add this 18 over. So we're at 3y equals 2x plus 22. And now I just divide the 3 everywhere, and then that brings the fractions back, but not until this very last step, and then I don't actually have to do much in the way of math with them. So once you get a slope that isn't going to clean up nicely and the math's going to get a little cranky, that's where the point slope is kind of nice, and then you just clear the fraction and bring it back to the last step. Okay, this one's the same basic steps, it's just the prompt is a little bit different. So here we're asked to find the line passing through this point right here. So that point is 2, -1, and parallel to the line displayed. So we're trying to find the line that would go kind of like this, basically. And so if it's parallel to this line, that means if I figure out the slope of this one, then this one has to have the same slope. So we'll go from right there. That looks like a good spot. So it looks like my run is 3 and the rise is 2. So that makes our slope, m is rise over run, so 2/3. And then looking at how that's going to play, this 3 isn't going to go into the 2, so it kind of makes me want to do point slope form again. So let's go y minus -1, so minus -1 would make that +1, equals m, 2/3, and then x minus x1, so that would be 2. And you see how if I distribute, that's gonna kind of stay bleh. So instead, I'll just multiply both sides by 3, and that cancels out that 3 right there, and then I have 3y plus 3 equals 2x and minus 4. And I'll bring my 3 over and collect terms. So 3y equals 2x minus 7, and then divide everything by 3. And so then that would be the equation of the line that would be parallel. And so you can see that y-intercept isn't very nice to graph, but that's okay, we don't have to graph that. We know it goes through this point, and we know its slope is 2/3, so I can just start right on this point where it's nice and go over 3 and up 2. If I want another point, and go down 2 and back 3. And then there's that -7/3, and draw a kind of halfway straight line, which, yeah, that looks like about -7/3. Okay, and then this last one, find the line passing through the point that, and that is x is 4 and y is 3, and then perpendicular to the line displayed. So let's see what we got here. Looks like this one is dropping. So it looks like it's running 4 and then dropping -5. So for this one, the slope of the line shown is -5/4. So then that means the slope perpendicular would be +4/5. And again, you can kind of see when I multiply that to that 4, I'm going to end up with a 16/5. So this is going to turn into one with fractions again. So I'll do it the same way I did the last one. So I'll do y minus 3 equals our slope, the perpendicular slope, 4/5, and then x minus 4. And now for here, oh, since this is a 5, this time I'll multiply both sides by 5. Clears out that, and I got 5y minus 15 equals, the 4 would survive, so 4x, and then minus 16. And let's add the 15 over. 5y equals 14x minus 1, and then just divide the 5 everywhere, we got it. And so there is our equation of our line. And then again, to get this graphed, I don't really want to graph that -1/2. So I'm just going to use the slope in this point. The slope would be, it would run 5 and go up 4. So it could also drop 4 and go back 5, and that would be the same thing. So if I do that, if I go -4 down and then -5 back, that puts me there. And then you kind of check yourself by going, okay, 1, 2, 3, 4, 5, up 4, yeah, got everything in the right spot. And then this should look pretty perpendicular. In other words, meets a 90-degree angle to the line given.